Okay, I am coming back on, and we are going to go to our next panel, which is nature-based solutions. And we have Luca Cittoni, Senior Advisor and Manager of the Strategic Research Program Sustainability at Deltares. And he's going to be speaking on developing nature-based solution strategies in the Netherlands. He's going to be followed by Rudy Simino, Jenny Heyman, Peter Moe, and Luisa Valiela. Luca, thank you very much for joining us. I know it's late in the Netherlands, and we appreciate you staying up.
Thank you, Stes. It's almost Italian dinner time, so we're still good.
And Greek dinner time too.
And Greek dinner time too.
Luca, did you want to share your screen, or would you like me to run the slides?
Just run the slides. I think it's okay.
Oh, okay, will do.
Okay, thank you. And while my screen comes up, I thank you for the invitation and also for the panels. I think the panels before my presentation gave a lot of assist that I can use in these few slides. And as you notice, I only have few slides. I could talk about this for about 3 hours, but I would try to do it for 5 or maybe 8-10 minutes or something like that. But I really try to touch upon a few things, and then hopefully facilitate a discussion that comes after that. So maybe if we can go to the next slide. First of all, what is building with nature and nature-based solution? So building with nature is defined as a conceptual approach for creating, implementing, and scaling nature-based solutions for water-related infrastructure. And I think what's very important here is with proactive use of natural processes. And that is a small movie normally, but we have PDF today. So you see very well how waves. It's a flume. You see some waves to the right side. There's some vegetation in front of a dike, and you see clearly how the vegetation decreases the height of the waves on the dike. And that just came up in the previous panel. That's an assist that I got 10 minutes ago. And indeed, if we have vegetation or a salt marsh in front of infrastructure, we can see how that helps the resiliency of our infrastructure. So we may need a lower dike behind that. What it's not the case though, and that's very important, is that we can just get away with green. And so what I always say also, that nature-based solution is really the optimum combination of green and gray. I really do not want you guys to go home and think that if we have a hurricane, we can just get rid of the dikes. That is not the case. We need to look at the optimal combination of which kind of salt marsh, which kind of help we can get to best protect us, still with some traditional civil infrastructure behind it. And then if you can go to the next, that's the other definition that I would need today. And I also have a lot of assist on that before today already. What's beneficial sediment use? I see in working in a PIANC working group to work on beneficial use. And we define that as the use of dredge or natural sediment in application that are beneficially in harmony to human natural development. What's important is not throw it away. And Jamie already gave us an example of how can we use sediment beneficially in, for example, construction of a harbor. There's a variety of uses we can have. What we've seen so far are the more traditional engineering use. What you will see in my presentation more is the combination between sediment and nature-based solutions, because nature-based solutions in water infrastructure are essentially made of sediment and vegetation. So sediment is really the foundation of that. So I will need those two ingredients for the presentation and discussion of today. Next slide. Now, those are some examples of projects we have in the Netherlands that are nature-based and sediment-based solutions. The top left is probably the most famous we have. It's about 10 years old. It's a mega nourishment on the Dutch coast. It's been done about 10 years ago, and now we are following its development. So waves and currents are reshaping the mega nourishment, and eventually, with the help of wind, that sand will reach the dunes behind it and keep the coast of the Netherlands safe. So instead of dredging a little bit every year, there's a trial of doing a mega nourishment and see how that develops and do nothing for a while, and using the natural forces to transport that along the coast. To the bottom left, it's a pilot also we work on, where the dike, there's a small dike in between two bodies of water that need to be reinforced. Instead of increasing the dike, we tested to have a beach in front of this dike. It appeared to be good, to be a good solution, and now the beach has been extending for a couple of kilometers in an upscaling of the same project based on the results of the pilot. I don't have a picture of that, but the project is complete now with extension of that solution when possible. That was not done for the whole dike, only when the conditions were possible. So again, the combination of nature and civil infrastructure is really important. To the bottom right, that is a salt marsh that's been built in front of a dike that's dividing an estuary with the land, which is below sea level, by the way, after the harbor. And that is part of a redevelopment of the city that you see just north of the wetland. And in this case, we tested different combination of sand and mud and vegetation to see what's the best way to build the wetland and to create a wetland in front of a dike. And then to the top right, that's a project that we are developing. That's one I spent quite a few days a month on this project. You see some drying field, dewatering fields in front of a dike. That is dredge sediment that's coming from nearby, from actually a improvement of a natural area. We needed to get rid of the sediment, so nearby we put in the watering field, and in about next year in the summer we will widen the dike behind those dewatering field, because that dike is not enough anymore for effect of climate change. So it needs to be widened, and we are trying to do that with clay, with local clay that basically dry the locally available dredge sediment. And we're thinking how to do that. And if you make a broader dike, it's also a wider dike, I should say, I mix up languages sometimes, a wider dike, then you have a better connection with the wetland in front of it. It's good for nature as well. So those are some kind of examples that you see a combination of using nature and natural processes, civil infrastructure, and different types of use of sediment. I should also say that at this point we are looking together with the authorities of the north of the Netherlands to scale up these solutions to regional scale. So those are pilots. What if we have to make all dikes in that region in that way? Can we get enough sediment? Can we get enough room to dry the sediment? How does it cost? Can we make that solution operational forever? Let's say. Next slide. Those are the examples. Now, few characteristics of nature-based solutions. Again, I go very quick, but there's 4 characteristics of nature-based solution that characterize the solution. One is that they're dynamic, so they change in time. Sand move, vegetation grows and dies, but the governance and the system is also dynamic. You have election, you have changing economy, so there's a dynamicity with that. They are innovative. Innovative means also that sometimes we don't have code, so we don't have legislation already available for that. They are site-specific. Each location has different physical and economical governance, physical force and economical governance structure. And the one I like the most, they are multifunctional. And that's where I would like to have the attention for the discussion. But you see there, I put different benefits the nature-based solution can satisfy, and different benefits, multiple benefits, make a better business model, a value-based business model instead of a cost-based business model. And I'd like to discuss about that later if possible. Next slide. And that's just one slide on the overview of what's happening in Europe at level of legislation. We all are trying to achieve sustainable development goals at global scale with the Paris Agreement. Now there's Glasgow conference just now, the G20 last week, that confirmed the importance and the centrality of sustainable development. In Europe, those are being, there's legislation being developed called the Green Deal and the taxonomy that essentially will drive how all organizations, private, public, should behave to achieve the sustainable development. There we define 6 goals: climate change adaptation, mitigation, circularity and reuse of resources, no pollution, biodiversity, water and marine quality. And nature-based solutions are central in most of these 6 ambitions that will drive everything that all organizations in Europe will do in the coming times to achieve the international ambition we discuss with each other. And that commitments then will be passed to each member state of Europe. For example, the Netherlands, which the minister of the Netherlands there that says also nature-based solutions are clearly part, nature our best ally, a clearly nature-based solution are part of our strategy for development. And then I conclude, as in any report presentation, next slide, sorry, yeah, next slide. I conclude with the references, and I just want to point out the book that we just made with EcoShape, and there's all experience that we've done the last 10 years. So take a look if you like. It's a book that's nice to read. It's got 6 enablers. How can we mainstream nature-based solution? It touches on the technical topic, on stakeholders, on business case, and eventually on institutional embedding, and provides different concepts. And obviously, I could talk about that for 3 hours, I promise, but I will stop here. And thank you for the opportunity to share these thoughts with you today.
Luca, thank you very much for this. Would you send us a link to that book that you referenced? And I will make sure that we distribute it to everybody who's on the call today.
Yeah, I'll do that in the chat immediately. Thank you.
Thank you very much. Okay, so our next speaker is Rudy Simoneau, who is Engineering Chief at Louisiana Coastal Protection and Restoration Authority, CPRA Master Plan to address flooding and land loss coastwise. Rudy, good morning from California, but it's a little bit later for you.
Yeah, it's early afternoon. Good morning to y'all, or good afternoon to y'all, depending on where you're at.
Rudy, you want me to share the slides?
Yeah, I'll share my screen if that's okay.
That's fine.
Okay, hopefully you guys can see my presentation. And
we can.
Again, thanks for having me. Similar to the previous speakers, I will go through this. This is definitely a presentation that could be longer than 8 minutes, so I'll breeze through it and be happy to answer any questions there. So
thank you.
So some perspective of what is CPRA in the background of our agency here. In Louisiana, after Hurricane Katrina, as Mark discussed, there were multiple state agencies responsible for the various coastal problems. After Hurricane Katrina in the 2007 timeframe, that was consolidated to a single entity, the Coastal Protection and Restoration Authority. We're actually within our governor's office. We're about 180 people, and we are responsible for delivering and implementing all projects, coastal protection and restoration in the state of Louisiana in our state's coastal zone. Now, why do we exist? Why is so much attention to coastal land loss? Well, if you rewind back to the 1930s, Louisiana's lost 2,000 square miles of land. You see here everything in red was once wetlands, has converted to, for the most part, open water. You do see some green there towards the middle of the map, the Chafalot Basin, which is an active delta. You do see the Mississippi River Delta also building land as well. We'll discuss that in a little bit. Using predictive modeling in a variety of assumptions, primarily subsidence and sea level rise, you can see we stand to lose as much as twice that in the next 50 years if nothing's done. So that is the impetus of our master plan. We have identified, in addition to the land we've lost over the past several decades, we look at the future with climate change, with sea level rise, and once again, Louisiana is some of the newest land in the United States. It was built by the Mississippi River, probably within the 10,000 year time frame. So it is still heavily subsiding and sinking beneath us. So relative sea level rise rates are quite extreme in some parts of our state. Why is our land being lost? You can see, I think the first and last bullets here are probably the most important, are the ones we'll touch on the most. You see a lot of man-made or actual industry-related oil and gas extraction, as well as the BP oil spill of 2010 caused major damage to certain parts of southeastern Louisiana. But when you look at that red map, the main culprit is sea level rise, subsidence, and then the lack of new sediment. I think that's the thing that we'll probably focus on. Louisiana always was sinking beneath us. The sea level rise may not have been extreme decades ago. However, there was always a new supply of sediment coming into a very natural system. That does not exist anymore. I think this map explains that pretty well. You look to the left, that's what our state looked like in 1930. What you do see as you look towards the left side of that map, several distributary channels that once were the Mississippi River. The Mississippi River was unconfined. It actually swept back and forth across southeast Louisiana and built the wetlands that were once so vibrant and important as a buffer to our state. Probably about 700 years ago, maybe 400 years ago, the river settled on the Plaquemines Delta, which is the current Delta Pass. You can see there, and even in the 1930s, you can see that the river was not levied. You see a lot of connection between the wetlands and the river, and you see actually our state was growing land substantially. The Great Flood in 1927 and ultimately the Flood Control Act in 1928 initiated a large-scale levying of the lower Mississippi River. From a development standpoint, from the standpoint of our ports, from the standpoint of the city of New Orleans and even Baton Rouge, where I live, we all can agree that those levees are important. The problem, the unintended consequence was that an annual supply of flood sediment, flood-driven sediment that built those wetlands was now cut off, and it all empties out into the Gulf of Mexico. So I think as I get towards the back end of this presentation, you'll see we want a strategic project or program that balances the ability to still live in Southeast Louisiana with having a natural connection to the Mississippi River, with a reestablishment of that natural process of river sediment flowing into the wetlands. That's where our master plan comes in. Once we were created in the 2007 timeframe, we were required to put forth a 5-year coastal master plan in terms of how much money we're going to spend and which project we'll put on the ground in a 50-year period. That recently was changed to 6 years. Every 6 years we updated, 2017 being the last edition, 2023 being the next. You can see here, when you look at the master plan in terms of breakdown of cost, it's a $50 billion plan. We'll start at the right, risk reduction, which would be projects that basically, similar to what Mark was discussing earlier, mitigate flood damage or prevent flood damages from storms and other extreme events. You see 2 categories there, structural and non-structural. I think most of the things Mark discussed were structural: levees, pumps, walls, all the things that I think are critical to the city of New Orleans and preventing damage from storms such as Ida. But you also see a non-structural component, non-structural being defined as perhaps moving people from high-risk areas or home elevation, perhaps modifying private property to be more resilient. A lot of the people who live in Southeast Louisiana do not want to relocate. If a family is traditionally shrimpers and have caught shrimp on the coast in a community such as Houma, they cannot relocate to Baton Rouge. So I think modifying or adapting is where non-structural comes in. When you look at the left side of the funding split there, you see a variety of projects. Some of them look very familiar to you: Bear Island, ridges, rock on shorelines in the form of shoreline protection. But you see, of the $25 billion in restoration, $18 billion is spent on marsh creation, and that's dredging. That has been what our agency has done over the past 15 to 20 years, has been dredging. We've dredged, I think the next slide shows 157 million cubic yards to date. And for the most part, that doesn't include 65 million that I have under contract right now. 65 million cubic yards under contract right now, all creating new land, new wetlands in the state of Louisiana. That's benefited, that's got us close to about 50,000 acres since 2007, 60 miles of Barrier Island. So much progress has been made, but when you go back to those original red maps, much more has to be made in order for us to be sustainable here in Louisiana. We use the term marsh creation. Simply, that's the hydraulic dredging of sand or mud pumped into some designated open, shallow open water area, usually confined with small levees, and then allowed to dewater and decant and then vegetate. So here's a picture of a project. We put a dredge in the Mississippi River. We didn't dredge to 90 meters. We did do this project did dredge to minus 90 feet, which is pretty deep in terms of the equipment that operates here. It's a 30-inch cutter section dredge that pumped about 1,000 acres of marsh near the lower southeast part of our state. So you see here, we're right at the end of the pipe. You see mechanical equipment moving the sediment around. Once the equipment was demobilized, we had a very flat surface, very much in the process of dewatering and decanting. And about a year later, we've got some very functional wetlands here in this area. Looking at it from the sky, the bright green area you see there is the southern shore of that lake. That was all open water before the project. So that's the concept of marsh creation. When we look at that 50,000 acres that I referenced, that has been predominantly what we've done. Those are great projects. They've performed well. Moving into the future, we want to look at the sediment diversion concept. This is that reconnection to the river. Why sediment diversion? So reconnecting to the river, I'll kind of look at a few of these bullets, but I think looking at maybe that last one is probably just as important as any. A lot of people refer to this part of our state as an estuary, but since the levees were built, I don't think we can consider it an estuary. There is no riverine input into this system. So we want to reestablish this as an estuary. We want to, in addition to the land building aspect of it, we want the habitat there, the fishery, everything else that goes with what was once a healthy estuary. We're proposing 2 projects at this point. These are projects that are going to remove a part of the levee, have a man-made canal excavated, and a gated structure installed, and then we would open and close the gates strategically to build and sustain land in these areas. So we're putting the river back to work at 2 locations in our state in southeast Louisiana. We get asked the question, how do you know it's going to work? It's a $3 billion investment between the 2 projects. So you look at the right side of your screen, that's where we're at in the Barataria Basin. That's the West Bank project area. You can see that part of our state has seen some of the largest land loss. When you go back to the red map, it's very red at that point. When you go over to the middle or left side of the screen there, you see that Chafalaya River, which was a historic distributary of the Mississippi. There still is a connection in the middle of our state to the Mississippi. 30% of the Mississippi River flows come down the Chafalaya. It's not leveed. It floods every year. It has distributaries all throughout. In addition to the impressive deltas that you see growing there in two different locations, you see the surrounding wetlands are also very much vibrant, very much functional. So that's the effect we want to put into the Barataria Basin and ultimately the Breton Sound Basin on the east bank. We'll focus a lot on the Barataria project. This is our engineer AECOM on this project. We have passed the 60% design phase. It's a CMAR project or early contractor involvement. So our construction contractors on board providing this input. You can see here about a 2-mile man-made canal will be dug from the river to the basin. The Mississippi River is flowing to the left of your screen there. You can see it's not as easy as just digging a giant ditch. We have a 4-lane highway bridge towards the middle of the screen, as well as a railroad bridge right at the river that we have to facilitate. We have multiple oil and gas pipelines to relocate, as well as telecommunications, water, natural gas infrastructure along the highway. as well as guide levees to be built. So major infrastructure, this is the lift gate system. You see the gated structure there, and the invert and the inlet feature have been designed to maximize the amount of sediment in the actual channel as it carries it from the river to the basin. Looking at the timeline, there's a lot of stuff going on here. The EIS is probably the most important component of this project. We applied for our EIS in the 2016 timeframe. March of this year, we received the draft. That draft, the comments that come with that draft are being reviewed as we speak. We're anticipating perhaps a final EIS sometime next year and the ability to go to construction with a record of decision in the middle to late part of 2022. I'm not an EIS expert by any means. I'm a civil engineer by trade, but I can't speak enough to be dangerous here. But just to give you some perspective, the Corps is the permitting authority on the EIS in collaboration with several other federal agencies. We are the applicant. It is a very, I think, a very involved process that involves many different public touch points. Ours is particularly complicated because these dollars this project is funded with the BP All Spill Settlement dollars, and the Louisiana TIG, the Trustee Implementation Group, does have a seat at the table in the EIS process. So in addition to the Corps being the permitting authority, we also have a funding authority at the table as well, with multiple federal agencies involved in that. When we look at impacts or potential impacts, this is just a short subset of some of the impacts that were analyzed. You see everything from noise and environmental justice to essential fish habitat, marine mammals, and navigation. So all of these impacts were analyzed throughout the EIS process. But the good news is the benefits. We feel that even with a very aggressive sea level rise scenario, 1.5 meters over 50 years, I think in Louisiana, that has about a 1% chance probability of exceedance. This project will build 17,000 acres. If we were to go to a more moderate sea level rise scenario, that number goes all the way up to 30,000 acres. So once again, when you look at the production of a dredging project, which gives us about 1,000 acres, even on the larger scale, we feel that we can create much more sustainable land over a longer period of time with these projects. I will touch on the Mid-Breton project. We're about 7 miles upstream on the east bank of the river. Both projects are being designed concurrently and managed programmatically. Our design team, Stantec, and their subcontractors have been hard at work on this. We've recently completed the 30% phase. Very similar feature, much shorter conveyance channel. Then looking at some opportunities to put the highway bridge on the structure to save some funds. It is all in all a much more cost-effective project in terms of dollars spent versus acres created just because of where it's located. That project is about 18 months to 2 years behind schedule. We anticipate perhaps record of decision and construction approval in the 2025 timeframe. And I think that's my last slide. That's a lot of information in a short period of time that I could easily break away multiple 1-hour presentations, but I would be happy to answer any questions now or towards the end of the panel discussion. Thank you.
Rudy, thank you very much for this. That is a very, very complete look at a very complicated and long-term problem that is really a national challenge. And you've done very well to bring this into such a concise summation. Thank you very much. And we will come back to you as soon as we finish with this panel. Our next panelist is Jenny Heyman. And she's a landscape architect at Stantec. And she's going to be talking about Staten Island shoreline, a layered approach to risk reduction. And if I could just ask our speakers, we are running a little late. So if you could try to stay within about 8 minutes, we would appreciate it. Jenny, welcome. And thank you very much for participating.
Thank you for having me.
Jenny,
Todd,
did you want to share the screen or you want me to do your?
you can share your screen.
Okay,
Fine.
will do. There you go.
All right, well, I'm going to talk with you about the Tottenville Shoreline Protection. You'll hear me refer to it as TSPP. The project was developed based on response to Superstorm Sandy in 2012. The client is the New York State Governor's Office of Storm Recovery, which I refer to as GOSR. The the end client, which is the property owner and the maintenance partner, is New York City. So our funding is through both state and city. We did get the New York State funding through the HUD program in response to Superstorm Sandy. You can go to the next slide. So just some location maps, just as a preface, this project was, or this presentation is geared towards the Public Design Commission for New York City, which is a design review agency for public projects. So there's a lot of eye candy and that kind of stuff. So just to get you guys situated, New York City, the 5 boroughs on the right-hand side of the screen, you see Staten Island Way at the bottom there. Our project site is even like the most southern tip of Staten Island. The impacts, though, you see the 2 barrier islands off to the side there is directly open to the Atlantic Ocean, and so they receive a lot of powerful waves. And then on the other side of the screen, you'll see we're immediately across from Perth Amboy is actually New Jersey. And so we're immediately across from New Jersey, but we sit on the Raritan Bay. Next slide. So this project, you see that highlighted in yellow is the extent of our project. So we are immediately next to Conference House Park, but the area immediately adjacent to the project are homes, their backyards, it's a community that we're protecting. It's not necessarily the type of public beach where you would have lifeguards and people coming down to go swimming. It's more of a passive public space. It's not highly used at the moment. The community uses it to walk along the beach, which is, with the erosion of the beach is getting limited. And if you've seen the movie, The King of Staten Island, they actually filmed on this beach. So it's kind of, it's not heavily used. Like the scene where he tattooed the kid happened right on our site. So most people just use it for yoga, just pull out their lawn chairs. But it is a big community asset that considering the views and just the quality of life of the community that's there. So you can go to the next slide. In terms of property ownership, so this is New York City Parks public property with a New York City Department of Transportation right-of-way. Only one small segment of the right-of-way is built out. This is an important fact because most of the homes that are along this property have a bit of a contentious relationship with the project, although we are protecting those homes as part of this project. Most of them have encroachments on the property, public property, and are under the assumption that they have private beach access. But here you can clearly see it's public park and publicly owned right-of-ways. You can go to the next slide. Yeah, here you go. So just looking at some of the flooding. So we are, this is an area that floods heavily. It's regularly had storm impacts. The magenta line, which is a little hard to see, is the limit of moderate wave action, which is what we're really responding to in terms of this project, in addition to the erosion. So next slide. So the goals of our project are to ecological enhancement, the risk reduction, which we're responding to the 25-year storm, or 25-year still water elevations plus sea level rise. And then the social resiliency aspect, which is this is a community and a public space. So to make it a park is critical to the goals. So next slide. Just reviewing the risk areas. So in zone 1 and 2 have very similar risk areas. Those were most heavily impacted by wave action. They do have erosion impacts as well, but part of the damage from Sandy, the wave action hit this area the most. One of the homes was actually knocked off its foundations and a family died. So that happens in zone 2. And then zone 3 is primarily just impacts of the erosion of the beach. You can go to the next slide. So this is our overall concept. We are at 90% in terms of design, starting 100%. Our sister project, which is also a Governor's Office of Storm Recovery project, is the Living Breakwaters, which is under construction right now. You see the little oyster habitat beds in in the water. That's part of our part one peg of our layered approach. But additionally, looking at a community, the typical seawall type of approach to protect these homes wouldn't really have been appropriate here because of the views and the community access in terms of the beach, and it's an asset to the community. So we did look at a layering of different types of systems in terms of the beach width and kind of what amount of space was accessible for the project. So you can go to the next slide. The first part is an earthen berm. It is a armor core center of this planted mound that wiggles through the coastal forest, and tree protection was a big part of this. So we did have to kind of go through clearings and make sure we avoided it. But creating ADA access through the paths, a continuous path throughout the whole project, which is a Parks client driven agenda item. So keeping it, the community be able to access the site as well. You can go to the next slide. Just a little closer look at the armor core system and then the planted mound through the trees. Next slide. Just one of the views up the ramps. Next slide. Now to the eco wetland revetment. So this is a system that there is an unmapped wetland, which is kind of the lighter blue area. We did have to make sure we minimized our footprint here because it is a pinch point. There are community decks built up almost overlapping the property line. Plus we had to minimize our impacts for the DEC requirements for the wetland. So we had a more larger structure that goes through the wetland to bypass it. So we're not having heavy construction within the wetland. You can go next slide. So there you can see, we have a path that stays along with it, but the backside of the revetment is planted as well. Most of it is so that we are hiding the views of an actual structure. And so there's a nice public face to these structures, so to the backside of the community, and then restoring the wetland in front as well, which has a land bridge now because of the community kayak launch desires. Next slide. So there's a view at the wetland eco revetment and the path associated with it. Just off to the right of the screen would be where someone's deck is. So we are trying to keep the public access a little bit lower from view. Next slide. Beach access needed to be maintained. So part of it is making sure that the community can get up and over the structure. Not all of the accesses were required to be ADA accessible. So this was one of the stair accesses. Next slide. So this is the hybrid dune. The original project right now is a temporary dune installation, which is trap bags and sand, and it's pretty much falling apart. So this was one of the original segments of the project, which was just to create a hybrid dune with a path behind and drainage systems behind the dune. The striped area is part of the sister project. They are doing some beach replenishment to allow for the footprint of our structure. Next slide. So you can see here we have the rock core for the hybrid dune covered with sand, and then beach grasses with the drainage structures behind, and then the community access path that's ADA accessible just behind it. Next slide. Just a view of the dunes. Next slide. This is the eco wetland revetment. It is the narrowest part of our project. The right of way for the road is actually built out here. And so we are keeping our skinny profile maintained. It's just a rock revetment. There was an existing plaza there, so we are maintaining that. And it's in conjunction with some of these roadways have outfalls. And so you can do next slide. So maintaining access for DEP for those outfalls. So you can see the structures as they kind of go up and over a much smaller footprint than some of the other segments, because as we get closer to the raised edge, our elevations that we need to meet are lower. You can do the next slide. Next slide. views of the plazas. Next slide. And the last segment, which is the raised edge, which is addressing primarily the erosion aspects of the beach, just creating a higher bluff for the maintenance pathway as it goes through. Again, addressing, minimizing impacts to the existing habitats and vegetation, the trees that are there, and just kind of meandering our way around and protecting those resources and allowing for beach access. One of the key areas right in the middle of the page, the community of mansions that live there went in after Sandy and illegally placed their own fill. No one has claimed it, but part of the project is to remove that fill that's not appropriately sized for what they're implementing, and to restore it to the original beach line, because now there's no more beach there when it's high tide. Next slide. Just a look at the system. Next slide. You can do the next slide. Just a view of the one of the outfalls and beach access maintained at all the roadway edges. Next slide. And then a view at the end of the parking lot, which is existing parking lot where people park to look out at the water, and a community resource. Educational signage is placed at some of the larger nodes to look at the breakwaters. Next slide. And then just part of the design is to make sure that all the plants follow a native plant palette, because we are restoring a habitat. So this is just our planting palette. That's it. It was quick, but that was it.
Jenny, thank you very much. That's a very interesting project and a lot of information there for a small part of the world, but clearly a problem for people who are living on the beach who don't realize that there's sea level rise and things have to change. Our next speaker, excuse me, Peter Moe, Project Manager Engineering with Nature, U.S. Army Corps of Engineers, San Francisco District, Aquatic Transfer Facility, a strategy to expedite beneficial use projects. And again, please remember, everybody, if you could stay close to 8 minutes so we can get everybody in. Thank you, Peter. Welcome.
Peter, do you want me to
well,
share the slides?
Yes, please.
Okay.
Thank you, Todd. Well, thank you, everybody. It is my great privilege and pleasure to present some exciting work that we are doing in the San Francisco District Army Corps of Engineers on behalf of our great team of engineers, environmental scientists, planners, and other support. The Corps of Engineers is very keen on pursuing strategic adaptation to sea level rise in methodologies which we've been discussing here, which mimic the natural processes of nature, as opposed to previous philosophies where maybe mankind was a little audacious and thought that we could just kind of armor the coast and be doing well with just that. So today I will present very briefly 3 exciting projects that we've been doing within our district to help adaptation around the San Francisco Bay Area. Next slide, please, Todd. This was a very exciting project that we undertook starting in the early 2000s, the Hamilton Belmarin Keys Wetland Restoration Project. On the right-hand side of the screen, up in the upper part of the picture, you can see the old Hamilton Airfield, which was a U.S. Army airfield that was closed during the base realignment and closure process. And the adjacent land over there, that community, is a community called Belmarin Keys, which is a marine type based community up there in Marin County. So this is a landscape scale restoration project that the Corps of Engineers did in partnership with the California Coastal Conservancy. And the recommended plan, after studying many plans through feasibility phase, was to utilize dredge sediment from all the federal channels within San Francisco Bay and private dredging projects, if possible, to accelerate wetland development by delivering 24 million cubic yards of dredge material to this over 1,600 acre area. This is in, as I said, Marin County, in the portion of San Francisco Bay, the North Bay portion called San Pablo Bay, which is north of the Bay Bridge and the Golden Gate. Next slide, please. Here's a picture of a conceptual design of what the goal was with wetland and upland habitats. And it's a 2,600 acre combined site. The Hamilton Airfield portion of the site was a 1,000 acre portion of the site. And that was augmented with the Coastal Conservancy to include the Belmarine Keys portion to bring it up to 2,600 acres. The timeline to construct this project with traditional means was about 18 years. And there again, it's to deliver 24 million cubic yards of sediment over those 18 years, utilizing our annual dredging maintenance projects around San Francisco Bay from the Port of Oakland, Port of Richmond, Port of Redwood City, et cetera. Next slide, please. So this project has innumerable benefits to both the bay and the infrastructure. You heard Colonel Arnett mention the dynamics of storm surge and how we all know this group is no stranger. Wetlands provide a buffer to help dissipate that energy. So there's a protection to infrastructure, improves water quality. The project was to help improve access to the bay. There's going to be a bay trail along there. As we mentioned, there's the long-term management strategy in San Francisco Bay for beneficial reuse of dredged sediments. This project goes a long way to fulfilling that 40% upland strategic goal for that. And it does so in an ecologically sustainable manner that supports navigation and the vitality of the economic activity that maritime trade in the Northern California region and through the Bay provides to the region and the nation. The San Francisco Bay, it's been determined now, is sediment starved. And so that's another key driver to the Bay to keep sediments within the system, as opposed to taking dredged sediments offshore to an offshore disposal site that is managed by EPA, which is called the San Francisco Deep Ocean Disposal Site, which is about 60 miles offshore outside of the Golden Gate. So that is a very wasted resource when our dredge disposal practices utilize that disposal site. Next slide, please. So the traditional way to deliver such large quantities of dredge material to this upland site would be to utilize an offloader. This is just a pump that can dip into a scow, empty the scow, and pump it across the mud flats there, excuse me, to the beneficial use wetland restoration site. This approach has some benefits. It's very small footprint within the bay. We don't want to have bay fill in the bay, so that's one of the benefits. It has a lot of problems though. You can only offload one barge at a time. It takes 3 to 6 hours to unload that barge. This expensive piece of marine equipment sits idle for large periods of time. It can't really accommodate the needs of the construction on the site. I liken it to if you were trying to build a roof and you had to deliver each shingle one at a time. That would not be the most efficient way to deliver the building materials. Has a maximum throughput of about 1.2 million cubic yards per year. So that was what's driving that 18-year timeline. So very inefficient, very costly. Does have environmental benefits in the sense that you dredge the material, you don't rehandle it twice, you pump it ashore, but a lot of limitations to this approach. So yeah, next slide. I don't think there's anything else I need to say on that. So what we developed was a very good strategic idea, and we developed an EIS and an EIR to support this idea. We did extensive scientific studies with our federal partners at the U.S. Geological Survey and others to look at a new approach. And this is basically a basin, 1,000 feet approximately wide by 1,500 feet long, as you can see on the right-hand graphic. And this basin would be open 24/7 around the year to accommodate all dredging projects. And it has a capacity of, it's 45 feet deep, 40 to 60 feet deep. So it has a capacity of a couple million yards. So dredging projects could come in here as they with their scows, dispose of the material, and the dredging side of the operation would go on just as it does naturally with our in-bay disposal sites. There would be no delays to the dredging projects associated with having to hook up and pump out of an offloader. And likewise, the upland construction would benefit because you would now have a stockpile of building material. You could segregate the materials in this basin by material type, like fine silts and clays or heavy sandy materials, which are required to bring the elevation up to grade for the wetland construction. So it have an enormous benefit. And then you would empty this basin with a hydraulic pipeline dredge on an as-needed basis. And that process would run 24/7 so that your upland construction activities could be done very economically and efficiently. And it provides a disconnect. The offloader is like a linchpin that does not build elasticity or flexibility into the whole dredging, delivery, construction process and cycle. This decouples those two processes, lets them operate independently, and so therefore you gain efficiencies and economies of scale on both sides. Next slide, please. So as I said, the basin is to be dredged somewhere in San Pablo Bay. We were going to do that near the SF-10 disposal site. We, with the help of the untrimmed model that was developed by USGS and Michael McWilliams, who I see is online here today. Thank you, Michael, for all your support on this project. We were able to find an area that is relatively quiescent, where we anticipated we would not lose but maybe 1 to 3% of the placed material. So this material is stockpiled and then would be emptied on an as-needed basis with a hydraulic dredge in the 24-hour production. The basin is approximately 1,500 by 1,000 by 40 feet deep, has approximately 2.2 million cubic yards of capacity to accommodate dredging projects through the federal program, as well as other small private projects that take place within the bay. We could transport a throughput of approximately 4 million cubic yards annually. As I mentioned, the material types could be segregated to better facilitate the design features that we want to construct. And the basin could accept all types of dredging equipment. Like I said, there would be no limitations on access to the basin, which is great because we could accommodate hopper dredges in the bay, which are very much more efficient for certain projects, as well as smaller scows that accommodate these smaller private projects. Next slide, please. So this transfer basin facility, you can see at the bottom line here, bottom line up front, the overall cost was, the latest estimates were about $450 to $500 million to construct the Hamilton Beltmar Keys project over the lifetime of the 18 years. We can reduce that lifetime to 10 years and reduce that transfer cost down to $120 million approximately. That is an enormous savings in time, efficiency, cost. And frankly, I think we all recognize around San Francisco Bay, we're behind the curve with sea level rise. We need to act. We need to get aggressive and take large scale projects to help restore the margins of the bay to provide resiliency under sea level rise. We did get through the final EIS process with this. To be honest, what derailed it was the green sturgeon was a newly listed, potentially listed endangered species. The area that we were proposing is known to fishermen as the white sturgeon triangle. The two species do not necessarily cohabitate the same habitats, nor do they have the same migration patterns. We do know that there are green sturgeon that utilize the bay, but the risk to the green sturgeon was never really fairly assessed. But unfortunately, the Marine Fisheries Service really put a damper on this approach. And because of that, the Belmarine Keys portion, the 1,600 acre portion, the preponderance of the project, has still yet to be built. And the big driver of that is the cost, I believe. The Coastal Conservancy could weigh in on that, but obviously, in the real world, money does matter. We need to come up with methodologies that we can shorten the time frame, shorten the cost, and get aggressive toward adapting to sea level rise, because it is happening faster than most people predicted. And we might actually be on the short end of the curve of that, really, where it actually, the feedback loops in the system accelerate sea level rise. And we all are aware of that. There may be risks to the high side. So next slide, please. But this is a great concept, and hopefully we can start to re-examine that. Another more modest approach that we are undertaking is yes.
Peter, you've got to finish off, please. We're running a little late.
Okay. We're doing another more modest approach in the bay, where we're going to just place dredge sediment in the mud flats and let natural processes redistribute that. This is a picture of Corte Madera. Obviously, they are in deep trouble. Next slide. This is an approach where you would deposit in the nearshore waters and let that nourish adjacent mudflats and marsh systems. Next slide. These are our dredging projects that we could potentially use to do that, and potential areas to do that. Once again, this is a pilot project that we are entering the NEPA process to analyze and put forward for the 2023 dredging season. Next slide. Another exciting project where we have implemented an engineering with nature approach is along Ocean Beach, the western flank of San Francisco Bay. There's some $1 billion worth of waste water combined sewage treatment plant out there, which is very subject to El Nino events and severe erosion. Next slide. This is where we dredged the main ship channel to enter the Golden Gate and San Francisco Bay. And this area down there by the erosion is the area I'm talking about. And we're looking at dredge material management practices that can bolster and fortify the protection down there under sea level rise and El Nino events. Next slide. We just recently completed a pump ashore project to develop a 3,000 foot long berm, 30 feet high, 60 feet wide, to provide protection down there. Once again, this is $1 billion worth of critical infrastructure to San Francisco. It was Senator Dianne Feinstein's major infrastructure project when she was mayor of San Francisco in the late 70s, early 80s. Next slide. Here we are constructing the dunes. Next slide. And voila, there's a new beach for the public to enjoy that has dual purpose for recreational access, surfing, wildlife, ecological benefits, and storm protection benefits. Thank you very much for the opportunity to present. I do see I went a few minutes over. I do apologize.
That's okay. Peter, thank you very much. This is it's a very interesting concept. And because Belmarine Keys is now in this cost logjam, your idea should be reconsidered. I think that the cost benefit ratio is getting clearer and clearer. So thank you very much for that. Our last speaker for this panel is Luisa Valiela, Environmental Protection Specialist for US EPA. And she's going to give us a progress report on San Francisco Bay's regulatory integration team, BRRIT. Luisa, thank you and welcome.
Thanks for including me. Todd, would you mind sharing your screen with my slides?
Sure.
Apologies up front. Fewer pretty slides coming your way. I'm going to be talking about a process, but a process to help projects, much of the types of projects that have been introduced today, So as of 2019, so we're a couple years into this, we started the Bay Restoration Regulatory Integration Team, saying 5 times fast, too hard to do, so we call it BRIT. But the two key R's in there, the restoration and the regulatory, are really the secret sauce. We are focused on accelerating the permitting and implementation of restoration projects in the Bay. And we do so through representation of the regulatory community. Next slide. So how we got to where we were, the Bay Area kind of it's a hotbed of innovation, in case you hadn't heard, even on the restoration front and the regulatory front. But our restoration projects were being hampered by what we have as a regulatory framework. So that the regulatory process and permitting restoration projects was adding cost and by way of time in terms of getting the projects on schedule and on budget. The pressure was mounting. We are also collectively as a region trying to restore 100,000 acres of marsh, tidal marsh in the Bay, as not only for ecological benefits, which in the beginning certainly was, but it is now, the most obvious, resilient approach to combating sea level rise in our region. So the pressure was mounting on for addressing sea level rise as well. We luckily also had a funding piece fall into place with the passage of Measure AA for us in the Bay Area. That was a $12 parcel tax that passed in the 9 Bay Area counties and has created a funding stream for getting restoration projects built. Next slide. So with those drivers and the acknowledgement that our permitting processes were hampering getting more projects built faster and better, the regulatory community, along with the restoration community, worked together starting in 2017. It had been a gleam in other people's eyes long before, but really started to be a planning process in 2017. And we finally stood up the process, the BRIT team itself, in 2019. So August 2019, we actually had representatives of each regulatory agency, federal and state, for projects in the Bay Area. Next slide. So in 2019, these are the folks that were hired. So it costs about 1.5 million essentially to fund the salaries of these staff, and that is what the funding was put in place for. So the Restoration Authority basically ponies up half of what it takes, and then other interested parties, including Valley Water, the Metropolitan Transportation Commission, the Coastal Conservancy, I think I'm forgetting one, they made up the other half to fund the salaries, this 1.5 million for this, the 6 representatives from the federal family. So you'll see them listed here. We have NOAA Fisheries, U.S. Fish and Wildlife Service, and the Corps of Engineers. On the state side, we have California Department of Fish and Wildlife, the Bay Conservation and Development Commission, and the Water Board, the San Francisco Regional Water Quality Control Board. EPA itself participates on an ad hoc basis. We are not receiving funds as part of this, but helped get it in place. And this is a pilot effort for 5 years. So the funding that's been put in place will, starting in 2019, will take us to about 2026, I think. Next slide. So this is what it looks like in terms of workload now. We now put together an annual report on our progress that we deliver to the governing board of the San Francisco Bay Restoration Authority. And again, that's what Measure AA created, this funding stream for restoration projects. And the BRIT as a project is kind of a unique type of project that SFBRA is funding. Nonetheless, they have a governing board, and we produce this annual report to them to talk about the progress of the workload, the restoration permit workload. So as of August of 2021, this is what we produced for the governing board, that we have 17 projects in the pre-application phase, and that's really the secret sauce of having the BRIT team which is we have dedicated personnel. We didn't get into all the reasons why it takes so long to get these projects permitted. Not only do we have 6 agencies that it takes usually to get a project built, because you have to go through sequentially often through these each agency, but often these agencies are understaffed, and that is a legacy of many things, including how we value our regulatory community, and the fact that we certainly in at least for the federal family I can speak for, we have some antiquated statutes. So it takes a lot to engage each agency at the level that they need, and sometimes there isn't consistency in terms of the staffing at each agency. And even if your project takes a long time, you may very well have some personnel changes in those agencies. So this team and funding kind of consistency from the regulatory family is part of our response to acknowledging that it is a problem in getting permits written and consistency among permits, and basically that there's someone to call. You are identified with a point person once you get put on the list for being a BRIT project, and that begins your engagement through as frequent or as not frequent as you wish during this pre-application phase before your project is even ready to submit a permit application for each agency. And the map itself kind of is just an easy way to track how we're doing and report back to the governing board how the workload is, how the workload's going. Okay, next slide. This is the behind the scenes tracking that the BRIT team itself uses to track its own workload and identify pinch points for their own workload. But with the total number, well over 20 projects now that they are engaged with, either in the pre-application phase or the permitting phase itself, you can see that it's a decent amount of work. But so far we're keeping up, and we're glad that the BRIT team has been really responsive in terms of creating these tools that help us track and be transparent with the restoration community. Next slide. This customer service element we've been learning and building in these first 2 years of standing up as a team. The website itself, I encourage you to visit it. For project proponents in midstream, essentially, there is a pre and post survey that the BRIT team gives them, so that everyone always has an avenue for giving constructive feedback if you're in the process, but also as the BRIT team works through consistency and permitting provisions, those tools are now being made available on the website as typical monitoring requirements or typical BMPs, so that you can find out early for projects that are similar to what you may be thinking about what has been written into permits. Next slide. This is the last slide. The Policy and Management Committee actually is another one. When I say BRIT, it's an umbrella term, and it certainly refers to the permitting team itself, but it also refers to this group of people, the Policy and Management Committee, which is our higher level managers at each of those agencies that have also committed to the process and provide a place for BRIT to have a sounding board should issues come up, which they always do in permitting projects, so that there is vertical as well, so horizontal amongst the regulatory family, and vertical, if you buy into that regulatory agencies have a lot of verticality, you have a way to elevate issues and have people that are following the BRIT process, as well as maintaining this permit and policy improvement list, which is also kind of key in our secret sauce of really wanting to acknowledge that there are some brick walls that a lot of projects hit. And as has been mentioned by other speakers, we do have, not that we're alone, but we do have a lot of challenges of endangered species, of where we are with sediment, the fact that to do the 100,000 acres of tidal restoration that we need all the sediment that's ever dredged up by anybody put back into the system. We can't have any of it disposed out of the bay. All these problems kind of get compounded, and at a project level, we don't want to take up the BRIT's team time working on these kind of larger policy level issues. And so the Policy and Management Committee have compiled this list and commit to working through some of the issues. One a year has been the commitment to the governing board of the Restoration Authority. And also there's transparency on the website of that, what's on the list and where we are in the process of discussing and trying to find solutions to these difficult policy and regulatory issues. With that, I will close out, I think, with the last slide, which just has the website on it, should anyone, it's a very long website link, but hopefully you'll visit it. It's got a lot of good resources. Thank you so much.
Louisa, thank you very much. A quick question. Can you quantify how much time you may be saving through this process, through this BRIT process?
We're in the midst of actually kind of honing that metric. So I like to say that no statutes or regulations or policies were harmed in the making of BRIT. So each agency's own regulatory timeframes, they are not impacted by the creation of BRIT. So what we are hoping to improve is that once you put a permit application in, that 60 days, that 90 days, that whatever each agency has in terms of response and getting that approved stamp on your permit, that happens. There is that any issues that normally hold that up, which is often pointed to as a problem, that questions come up that you've submitted a incomplete application because more information is needed. All of those issues have been taken care of in the pre-application phase, and that can take as long as it needs to take, whether it's a year, whether it's 2 years. We understand, and we're part of figuring that out. But by the time you're ready to submit your permit application, we are trying to be, within that, typical 3 months responsiveness of getting that project approved. That's how we're framing it.
So better preparation helps for a better result.
Yep.
Okay,
Yeah.
Thank you very much. Peter, where'd you go? The Aquatic Transfer Center, is there any chance that this is going to get refunded sometime soon?
I don't see anything on the current horizon, unfortunately, no. I know Amy Hutzel at the Coastal Conservancy has expressed that, too bad we don't have an aquatic transfer facility to make this project more cost effective. But I don't know, I'm not aware of anything on the horizon to resurrect this, but maybe that's why it's good to get it out here in the public sphere again, and to initiate that dialogue and maybe energize that process again.
Very good, thank you. Luca, would you do me a favor? And I sent you an email. Would you email me the book that you were talking about? Because I have problems getting the things off the chat and getting it into my reference point. If you could send that to me, and Rudy, your booklet as well, if you could send that to me by email. You both have got my email addresses. If you could do that, please. And we will distribute that to everybody because those reference materials are very useful, and thank you for those. Luca, quick question. In terms of regulatory issues, you've heard Louisa, are you in the EU getting a little faster on regulatory approvals?
That's a difficult question. So there's a few things to say here. First of all, I sketch in the EU as big level is something that's going on at very high level that will influence all organizations. That's what we call taxonomy. So that will be in place sooner, but that is high level. As far as the project I described, I guess I have to say that from my experience, permits was not a big deal.
Yeah.
What it's interesting though that I take the opportunity here to mention is that those projects are somewhat innovative, which means that, for example, the dredge material we dried up in clay for dikes should meet the standard for Dutch dikes. Specifically with a very low salt content. That's what it says in the permits, and in that case we don't meet that criteria, and so that maybe is an interesting comparison. So the various authorities that has to sign for the dike, someone has to sign for the safety of the dike, still wanted to go through with this demonstration project because they see the value of the technology and to build back dikes as a long time ago. And in order to do that, we did a specific research program to show the dike was safe before we could go into the field and build that. So more than a permitted problem is also how do we get innovation and innovative technologies still within the construction pipelines, let's say, the operational pipelines.
Okay, very good. Thank you. Rudy, are you seeing the approval process going faster for you? And, time is of the essence for South Louisiana. You took a big beating with the hurricanes this year. Is there a greater sense of urgency amongst the regulatory authorities to approve your project?
I think the answer is yes. In general, I think when you look at regulatory approval for our projects, you have the diversion and everything else. So let's look at two categories. So that diversion project at EIS was somewhat of an unprecedented, not just for our agency, but for New Orleans District as well as the Mississippi Valley Division. It involved a lot of moving parts and pieces. We talked about the extra group of federal agencies on there in terms of the Louisiana TIG for the funding. And then it was also a big, what I didn't mention was it was a big 408 component because it impacts the federal project, actually two federal projects, the Mississippi River Levee and the Mississippi River Channel. So that was somewhat extraordinary to have that many layers of permit complexity. Like I said, we applied in 2016. We were told when we first started that this was a 10+ year process. We got the draft EIS earlier this year. So I think we're heading in the right direction. I think a lot of that, Mark's not on here anymore, Mark Wingate, but it's the partnership that we established with the New Orleans District at the core that has led to those efficiencies. We've got a dedicated team over there. We've got a PM at the core who picks up the phone every time we call. And I think that has made that process a lot easier. On everything else, and we'll just maybe categorize that as the dredging, things have gotten quite efficient there. I mean, we're getting permits in, depending on the complexity of the project. Once again, some of our dredging permits do require 4A as well because we're dredging the federal projects. But we definitely can get those in a matter of 6 months sometimes, and some shorter. So I do think familiarity with the permit analysts and the projects are a big part of that in collaboration with the permitting teams. The big challenge for us in delivering all of our projects is 80% of coastal Louisiana is privately owned. So we are constantly dealing with private landowners, not just landowners, but owners and operators of oil and gas infrastructure. Dredging and pipelines don't go well together. We know this. So it is a big finding the oil and gas infrastructure, then finding who owns it, and then getting them to allow you to build a project is a challenge, as well as the private landowners. A lot of hunting, a lot of recreation goes on down in the marshes, so we have to make sure that those landowners are happy as well. But from the permitting side, I definitely think we have made major improvements on the state and federal level to get these approvals in place. And I think we're pleased with the progress of the EIS flood diversion project as well.
Very good, thank you. And Jenny, private landowners a problem with you?
Yes, they're a big problem for us. Community engagement has always been a huge component of the project and for both of the state and the city. In terms of the overall community, we do have our community board approval. The kind of greater network of the community approves it, but the immediate property owners have been a bit of a hurdle for us because they do have encroachments across the entire property. They have organized against the project. And through the years, they have had some police presence at our community meetings for protective reasons. And yeah, it's been a bit of a hurdle, but I mean, there are community members with property owner like that own property right on the project that are inclusive. So the reason we extended the earthen berm further into the forest is because the people that are kind of behind front line of those homes wanted more protection, were the ones that were a little bit more at the pinch points, were the ones that had concerns. It's not just the property encroachments, it's also there's this, like Staten Island as a whole is very tight knit in their neighborhood. So this neighborhood is called Tottenville, and Tottenville people like to stick with Tottenville people. And they're very much in that kind of mentality. And so the idea that the others would come and use this path creates a bit of fear. So has been some fear mongering in terms of kind of what's going to happen now that there's a public path that, there is one through the park that's immediately attached to our site that people use for the community all the time that doesn't attract the others. But there's this concern that now you're kind of putting it in an area that is not used as much. So I think they're having trouble visualizing that.
Very good. Thank you very much. Guys, we have to move on to our next, we have 2 more panels to go. So our next panel is flood risks and strategies. And we have 2 speakers addressing issues in Texas. Mary Davila-Cheridze, Assistant Professor, Department of Marine Sciences, Texas A&M University at Galveston. She's going to give us an update on the Texas Coastal Spine Project. Mary, good afternoon.
Good afternoon.
Yeah, good afternoon here in California as well as you in Texas.
That's great. At least we are on the same time of the day.
Yes.
All right. So let me share the screen if it's allowed.
Yes,
go
go
ahead.
ahead.
Oh, I have so many things. And thank you very much for the invitation. Let me open them. Slides. All right, so can everyone see? Maybe I should open
Yes,
the
we can see it.
I'll open the PowerPoint slides because it shows on the full screen.
Okay.
All right, so this is an update about the coastal spine in Texas. I'll just give you the brief introduction about the early developments of the spine. This idea of the coastal spine, also known as an EICDITE, was first proposed by one of our faculties at Texas A&M University at Galveston, by William Merrill, as a mitigation strategy months after the Hurricane Ike in 2008 struck the upper Texas coast and caused billions of dollars in terms of damages. One of the important characteristics of this hurricane was that it was Category 2 hurricane, but brought immense amounts of the storm surge, the level that were associated with the Category 5 hurricanes, and has impacted tremendously the entire island, Galveston Island, which is a barrier island, and flooded almost all the properties on the island and in the Bay areas. So the initial study was performed by Texas A&M University in collaboration with the Delft University in the Netherlands, in particular to design the sort of a structure of the coastal spine that would prevent this amount of the water to come into the bay and impact them and flood their properties from the backside of the island. And the design was of the around 17-foot barrier at the coast with the gates across the inlets, and design structure considered only 100 years storm surge event, and of course some of the events that we are going to expect in the future could be even higher in terms of their impact. So this was the initial design. So this is a Galveston Island, which is a barrier island, and there is a Bolivar Peninsula, and there is this sort of open area in between them, to where this huge surge event came into the bay and really overwhelmed this bay in terms of the water that flooded the side of the island. So idea is to connect this to land by the spine with the gates that can be opened and provide some sort of a so-called environmentally friendly solution for the also valuable coastal ecosystem that it was there. So this idea, of course, then gained a lot of tractions among the policymakers, local authorities, and led to a much larger study that was done by U.S. Army Corps of Engineers. And this study involved the entire coastlines of the Texas, and involves not only the coastal spine, which is a structural mitigation of the floods, but also the restoration of the ecosystem and some other vital services such as wetlands, dunes, and more nature-based solution for the flood problem and mitigation of these impacts. So this gray area is the bigger part of the coastal spine project that was done by U.S. Army Corps, because majority of the coast pretty much covers and involves the construction of the coastal spine. I'm going to give you just one of the alternatives from this report. As you can see, Galveston Island has also the seawall, so it involves raising the seawall, also constructing another seawall on the Bolivar Island with this navigation or environmental gates, as they called. It involves also some flood walls, levees, and extension of the seawall, which this is a current seawall, the yellow shade, and all these green lights would extend the seawall. So the gates would look like this. So they remain open during the calm times and when there are no surge events, but will be closed for a couple of days, 3 days, to avoid when there is a warning for the surge. This is very similar to what the Maasland barrier in the Netherlands has. So I think this would be sort of a close replica of that if it's funded. So one of the important sort of progression towards the implementation of this project is that this initial feasibility study of the U.S. Army Corps was initiated in 2014 and has evolved into multiple stages of the progression in terms of the updates of the report. And the most recent one was completed in 2021 in August, which was built on previous versions of the report. And it's sort of it has been already signed by U.S. Army Corps of Engineers, and it's set to be recommended to the Congress for authorization of the funding. And if this is approved, this would be one of the largest projects that has been constructed or built by U.S. Army Corps in the United States. So the estimated project timeline, as I've said, it has started in 2014. So it took almost 7 years for this study to be completed. And if it's approved if it's authorized by Congress, then there would be sort of a pre-construction engineering and design that would perhaps last 2 to 5 years. And after that, there is a sort of estimated time for the construction, 10 to 15 years. And in the last phase would be the maintenance, which is primarily the prerogative of the local sponsors. Of course, the funding is a big component of this project, and we expect, hopefully, it will be supported by federal funds, although with a match from the local governments, as the history of for example, Galveston Seawall has proved. I think 31% was contribution from the local governments. So important progression also towards the funding is that just recently this 5-county protection special funding district was created by the Texas legislature, which was signed by the governor, that creates sort of a formal mechanism for the matching funds. And also this district will be responsible for maintaining the structure if it's constructed in the future. And there has been already 6 appointments that were made to this district, and also the counties have also made their own appointments. I want to just give you the brief overview of the costs of this coastal spine. Generally, the total estimated cost of the Texas Coastal Protection Plan, which involves both the coastal spine as well as the other beach nourishment and ecosystem restoration, is estimated in approximately $29 billion. Of this, the majority, almost 80–90%, goes to the upper coastal Texas coast protection, or the coastal spine, with 26 billion. And the benefits and the cost ratio that U.S. Army Corps have estimated is above 1. So for coastal spine specifically 1.9, and for other beach nourishment and sediment management programs, it's 2. Independent to the U.S. Army Corps of Engineers, we also at Texas A&M have conducted this benefits cost ratio. However, our cost estimates were a little bit lower than this, the ones that was used for the for the U.S. Army Corps, primarily because we only considered the engineering cost of the spine, and we did not consider other nature-based solutions or beach nourishments and things like that. And we also accounted in the benefits estimation the shutdown scenarios for the petrochemical and petrochemical manufacturing and refineries that are prevalent in this area. It's one of the driving economic industries. And we considered these shutdown days based on previous incidents and the historically observed shutdown periods associated with Hurricane Ike and Hurricane Katrina. And in all of these different scenarios that we consider, okay, if the industry shutdowns for 18 days, 26 days, or 33 days, we estimated benefits and the cost ratio exceeds 1. Only place where it's like very close to 1 is when the cost of the production is the construction of the coastal spine is high and the firms do not shut down for a prolonged period. It's only 18 days. But we know that this coastal protection is not a local public good only because of the various important assets that are in the Bay Area, including, as I've mentioned, the refineries, this petrochemical manufacturing, also one of the largest the ports in terms of the export tonnage and export and import tonnage, which is the Port of Houston. We estimated also using this computable general equilibrium model how the impact of the storm surge events on this upper Texas coast would propagate to the indirectly to other sectors of the economy, and if this impact would be felt on the gross state product of Texas, as well as the gross national products of the United States, and what would be the ripple effects on other states. And we looked at the very long-term impacts of these surge events, and we estimated that these impacts, like immediate impacts, range from $18 billion for Texas state gross state product to approximately $83 billion in the 50 years time. And in terms of the national GDP for the US, it does not shrink that substantially. It's only 0.1% and increased to 0.26% in 2066, which was a time period, 50 years, that we have considered, primarily because the economy allows substitution of goods and services as well as the inputs of productions that are employed by economic sectors. So just as a last slide, I would like to sort of give the economic significance of the Galveston Bay in terms of the figures for those who may not know. This is a home of approximately 4 million people, 4.4 million people, and the expectation is the population will surpass 6.3 million by 2040. And this, coupled with the intensity of the events and the hurricanes and the frequency that are projected to increase in the future, will create significant stress in terms of the vulnerability of the assets that are at risks here. As I've said, it's a hub of some of the nation's largest refineries and petrochemical manufacturing sector, and also critical infrastructure such as Port of Houston. It has generated significant contribution in terms of the GDP to the state economy, as well as employs more than 62% of its population. So it's an important region for Texas economy and the economy of the United States as a whole. And in terms of the value of the chemical manufacturing, mining, oil and gas extraction sectors, the estimated value was about $294 billion. That was estimated in 2012 prices. So there is a lot at stake, and the benefits, of course, of the surge barriers are higher when there is so much to protect and avoid losses beyond the losses that we see in terms of the residential property losses or the losses to other structures. That's all I have. Thank you.
Mary, thank you very much. Very interesting. How close are we to getting Congress to consider the funding here?
We don't know that. I think we are just waiting. It has been signed by U.S. Army Corps of Engineers, so now they are going to pass it to Congress, and I don't think there is any timeline as to when this would be considered for approval.
Okay, thank you very much. Our next speaker is Tony or Antonia Sebastian. She's an assistant professor, University of North Carolina at Chapel Hill. She's at the Department of Earth, Marine, and Environmental Sciences, and she's going to be speaking to us about shortfalls of insurance coverage during Hurricane Harvey on Houston and some of the issues that are not being considered in flooding risk analysis. Tony, good afternoon, and thank you for joining us.
Hi, thank you for the invitation. I really appreciate it. And I will try to keep it somewhat short because I know we're running a little bit behind schedule. My name is Antonia Sebastian. I am an assistant professor at UNC Chapel Hill in the newly formed Department of Earth, Marine, and Environmental Sciences, which is a total mouthful. And today I'm going to talk a little bit about some work that I did in Houston, but also connect it to some work we're doing right now on the Carolina coast. So a little bit of a two-sided perspective to the same problem. I think in this group, I don't need to say this, but we all know that repetitive hurricane shocks pose significant risk to coastal communities. There have been numerous headlines over the past couple of years, especially since the 2017 season, that highlight the issue of coastal flood risks and how they could cascade and create really devastating impacts to coastal communities. And across the board, we tend to use the 100-year floodplain as our primary marker of risk in the United States. The floodplain is an indicator of those areas that are at highest risk, but the key thing here is that it's really poorly understood by the public, and often the public doesn't take the necessary steps to protect themselves against flood risks, like through buying flood insurance. So I'm going to talk a little bit more about flood insurance in the US and what we're kind of seeing here. Nationwide, we're seeing that about 28% of all insured flood damage is occurring outside of these high risk flood hazard areas. And the rate of damage occurring outside of the floodplains is growing. On the left-hand side here, you can see the rate of the fraction of damage outside of floodplain areas in green, growing over time. And on the right-hand side, you can see this, well, on the left-hand side, this is for all coastal counties. And on the right-hand side, we're looking at just counties in the Gulf of Mexico. So we kind of assume that these, or we're finding that these trends in losses outside of floodplain areas are greater in coastal communities than in other places. And part of the reason for this is that a large portion of the flood risk in the US is unmapped, particularly flood risk that comes from urban flooding or pluvial flooding, which is flooding that occurs because you have extreme rainfall ponding at the surface before it can reach the nearest receiving body of water or storm sewer inlet. But also we are not modeling compound flooding, which is flooding which occurs when you have extreme precipitation, riverine flooding, or coastal flooding, such as storm surge, combining in the coastal zone to create flooding that occurs away from our existing floodplain areas, which only represent river and storm surge based flooding and not these combination impacts that could be occurring. And most people in the US don't recognize that our floodplain maps aren't capturing these different sources of flooding. And therefore, if you live outside a floodplain area, you may choose not to buy flood insurance. And this brings us to a critical point, which is that flood insurance serves as the primary protector for most homeowners and also the communities in which they live and the community institutions that are supporting their existence at, for example, the coast. But coverage relative to the mapped risk remains low because people don't understand their risks or because people are choosing not to buy flood insurance. About 95% of all residential flood policies in the US are held by the National Flood Insurance Program. The National Flood Insurance Program is offered through FEMA, and it's a subsidized flood insurance program for US homeowners. And we see that only about 30% of the households in the floodplain are insured, and households in the floodplain with a federally backed mortgage are required to buy flood insurance. Compliance is, however, sometimes low. Uninsured damage and property value losses can extend to lenders and local governments, threatening the resilience of coastal communities. So Stas asked me to talk a little bit about the issue of uninsured losses that can occur, and I'll show you some results from a recent paper that we wrote. But the key point here is that we're seeing, or we're expecting, that these uninsured losses pose a greater risk to the coastal housing economy than we currently know. One reason is that uninsured owners might borrow against the value of their property to recover from flood events. So those people living in areas where there has been a lot of damage may choose to borrow against their equity during the recovery process. And also home values might be decreasing after flood events because they've been damaged or because their neighbors have been damaged, and communities are seen as more vulnerable than before the flood events. And this increases uncertainty about resale values. And our preliminary work suggests that the decreases in property values are more likely to occur in areas where property values are already low. So these tend to be marginalized and lower income communities, whereas higher income communities or valuable communities actually sometimes see increases in property value after flood events because houses are being flipped or turned over. But there's this interaction happening between the flood recovery process and home or property values that can lead to cascading losses, which might impact communities and local government because of loss of tax base or potential for property abandonment. So I'm going to show results from sort of two studies that we did recently. In one study, or let me start by saying there have been several recent storms that have sort of underscored this potential issue of cascading losses in coastal communities. One is Hurricane Harvey, another one is Hurricane Florence. There have been numerous others, but these are just the two I'm going to show some results from. Hurricane Harvey, as I think many of the people on this call know, made landfall in the Houston-Galveston area in August 2017. It is the largest rainfall event on record in the continental United States. It dropped about 1,000 or just over 1,000 millimeters of rain in 4 days. And several studies that came out after the storm suggest that this rain was 15%, the magnitude of this rainfall was 15% greater as a result of climate change. If you compare sort of a 1900 climate to today's climate. So climate change is sort of an exacerbator of all of the flooding issues that we're seeing in the coastal zone. We ran together with a couple of colleagues at TU Delft and at Deltares, we ran a model called Sphinx, which is a two-dimensional coastal model that can incorporate pluvial, riverine, and coastal flooding to estimate the total inundation from this storm event and the associated damage that occurred within sort of the greater Houston area, Harris County area. So we had a model domain that encompasses the majority of Harris County, the watersheds in Harris County. And we found that within this model domain, there was about $11.1 billion in residential flood damage. And when we compared this against FEMA insurance payouts, we found that only about 25% of the damage was covered by insurance, leaving 75% or $8.3 billion of the damage uninsured. And we also sort of concluded from this paper that the majority of this damage came from sources of flooding that were unmapped. So specifically the pluvial flooding and the flooding that arose from combined drivers of loss, which are traditionally unmapped sources of flooding. We also saw that areas with high rates of uninsured residential loss corresponded to lower income, more marginalized communities, although there were some unique things that happened during the storm, which also affected higher income communities. So it wasn't, across the board that lower income communities were disproportionately affected, but there was a correlation there. And that sort of is where we left it with Harvey for now, but I want to relate this to some similar work that we're doing in Eastern North Carolina, the coastal counties in Eastern North Carolina, looking at Hurricane Florence, which made landfall in 2018, and the potential for systemic risks to local government, local lenders, and property owners as a result of potential default or abandonment at the property level. So after Hurricane Florence, using sort of similar methods to what I described for Harvey, we've estimated that there were about $2.16 billion in losses, where we quantify losses as property value decline, so property value loss, uninsured damage, and insured damage. The majority of the losses, the direct losses from Florence, were due to uninsured damage and property value losses, and this insured damage portion is basically borne, that risk is borne by the federal government. Of course, when you have property losses and uninsured damage, as I described previously, homeowners may be borrowing against their equity or potentially facing value losses that put them underwater on their mortgage. So a fraction of these losses could cascade further through defaults or abandonment to these other parties. And we are estimating that there is about $850 million in financial risk, potential financial risk, or was after Florence. Not all of this risk is realized because not all of these people abandoned or defaulted, but what we're seeing here is that there's huge potential for cascading losses from these large storm events, where only a fraction has been covered by the federal government. So uninsured losses are potentially catastrophic. So just a couple of concluding remarks. I'm probably already over time, but we're seeing that there would be huge value in better estimates of current and future flood hazards to identify at-risk properties, both now and under future climate risks. Federal flood insurance provides critical protection to homeowners, and actually it provides protection to community institutions as well, because without federal flood insurance, these losses can cascade into other institutions. Climate change, of course, poses a systemic risk to communities, especially those located in coastal areas, and we need a better understanding of what these systemic risks are. Also, the Biden administration has recently put out a couple of calls for better understanding the potential systemic risks of climate change to federal institutions like the Treasury. And then finally, I would point out that this distribution of financial risk that we found for Hurricane Florence is unique for that storm. The financial risk distribution differs greatly from storm to storm and across different types of communities. We saw very different distributions for rural and urban communities, but I didn't have time to show that today. And climate change will probably exacerbate existing socioeconomic disparities in the future. And I'll just end by, acknowledging a couple of my collaborators at Deltares and TU Delft and here at UNC through the Center on Financial Risk and Environmental Systems. Thank you.
Tony, thank you very much. And a lot to think of. And just real quickly, Susan Sullivan, I tried to acknowledge you earlier, and I just want to just say hello. Susan's with the Acacia Group. She's on the board of directors of the Propeller Club, and thank you for joining us. Tony, thank you very much. And this leads us into our last speaker, Kathleen Schaefer, who's a PhD student in civil and environmental engineering at the University of California, Davis, a former FEMA engineer and flood insurance specialist who's going to talk about San Francisco Bay Area flood exposures and insurance strategies to address them, which we have just been prompted on by listening to Tony's presentation. Kathleen, welcome.
Thank you. Thank you. And if you don't mind, I'll have you run my slides.
Sure. Okay, I believe this is it here. There we go.
Thank you. So just next slide, we'll start. Just to follow on to the great presentation that we just heard, I thought it would be helpful to have a little flood insurance 101 to make sure that we're all kind of on the same page. Flood insurance is very confusing and there's a lot of nuances to it, but I just want to point out that the federal government provides flood insurance to everyone and anyone who wants it through the National Flood Insurance Program. It's a program administered by FEMA. And as many of you know, FEMA produces flood insurance rate maps. They give those rate maps to the community and require that communities adopt them and use them to enact building restrictions. What you may not know is that starting October 1st, FEMA, for the first time in 40 years, has changed the way in which they price their NFIP policies. It's a new program called Risk Rating 2.0, and it prices risk in a way more consistent with the way that the private sector prices risks. So if you have a flood insurance policy, or you know people who do, you may want to reach out to your insurance provider because you may be eligible for a discount. But many of you will also see your rates increase, as I will talk about in a moment. Next slide, please. So a couple of things about flood risk realities. Flood risk is a community responsibility. It's not a FEMA responsibility. And increasingly, the federal government is not going to come to your aid if you do have a loss, as our previous speaker kind of alluded to. There's a difficulty in getting people to buy flood insurance because, in part, good things happen to me, bad things happen to you. One of the shortcomings for the National Flood Insurance Program is that it assumes that everyone in the community cares. That once you have a FEMA map that shows that you have a flood risk in your community, it assumes that everyone will want to strive to reduce that flood risk. When in fact, we know that people tend not to care. It's not a very salient issue until it becomes the only thing that you think about in a flood. So we have a program that's complicated and not salient, and that means for local politicians, they get no reward for dealing with it. However, funding is increasingly available for mitigation if you have a local cash match, which is one of the challenges. Next slide. So why are we talking about flood insurance in a drought here in California? Well, next slide. Because in California, our drought is likely to end with a Godzilla and El Nino. Our research suggests that we are increasingly going to be subject to climate whiplash, where we go from drought to flood. Next slide. So finding an alternative to the National Flood Insurance Program is going to be particularly important for California. And where we have today, we have the problem with the NFIP is that too few people buy. And if they do, they pay too much. As a consequence, there isn't enough money left for mitigation. And for communities, they can no longer hide from their flood risk. Just to highlight that. The issue of hiding in the past, many communities relied on antiquated FEMA maps to hide the fact that they have a significant flood risk. A few months ago, the bond rating agency Moody's just spent $3 billion, and that's billion with a B, to purchase a catastrophe modeling company called RMS. That should send a signal to everyone that in future bond holdings and bond issues, that Moody's is going to consider the impacts of climate change on the community's ability to repay. Next slide. And the issue of too few, this slide shows the NFIP take-up rate for the 9 Bay Area counties. First, it shows that there are only about 45 NFIP policies, so consistent with our previous speaker in Texas. According to the flood factor, there are 258,000 high-risk properties in the Bay Area. So only about 20% of the Bay Area flood-prone properties have an NFIP flood insurance. We see from this chart also that in 2020, Bay Area residents paid in more than $65 million in NFIP premiums. Examining the claims data shows that this amount over 3 years would cover all claims that have ever been paid in the Bay Area. Next slide. So this short chart shows the monthly take-up rate for NFIP policies that are manually rated. These are policies that are in higher risk areas that are required to, homeowners are required to buy as a result of having a federally backed mortgage. It shows that as the price of the NFIP policies increase, the number of policies decrease. Next slide. This is a slightly different chart. It shows the monthly take-up rate for NFIP policies that are lower risk, those that have a special discount such as grandfathering. These are generally purchased by homeowners who feel they have a flood risk and choose to buy flood insurance. We see two things from this chart. We see a certain percentage of the population is risk adverse and will buy flood insurance. We also see that, that as long as the purchase price is relatively low, and that between $500 and $700, that's an amount that the homeowners seem to be willing to buy. This confirms previous surveys conducted by the Sacramento Area Flood Control Agency. And you see the big spike in the middle, and that was the year of the Godzilla El Nino. So people do respond to that kind of information. Next slide. This is a chart that shows the impact of Risk Rating 2.0 on the Bay Area community of San Rafael. It shows that 10% of the, or 7% of the policies under Risk Rating 2.0 will see a slight increase. But we also see, next slide, we also see that 10%, almost 10% of the policies will see a greater increase of almost over $20 a month. So price NFIP policies are going up. Next slide. It's important to note, or I want to call your attention to, in 2012, from 2012 to 2016, when California was undergoing the last drought, California residents paid in almost $1 billion more in NFIP premiums than they received in claims payments. And so the heart of my research is asking the question, what if we kept some of that money here in California working for us and using it to buy down risk? Next slide. So what would that, so getting back to the idea that there isn't enough money, and you've heard that in several other presentations, this is an area in Marin County that is in need of mitigation funding, and unfortunately, it's hard to come by. Next slide. So the idea is, what if we had a community-based insurance program, one that was managed and run by the community? This is an idea that's not new. It is in our governor's 2020 water resilience portfolio. It is also included as a potential funding mechanism in the California Central Valley Flood Protection Plan. And it is an idea that's recommended as a pilot in a very recent and groundbreaking publication by the California Insurance Commissioner's Office. Next slide. So why is a community-based insurance program attractive? Well, if we look at how insurance is priced, there are three components to a flood insurance pricing. There's the risk. What is the true actuarial risk? There's a certain amount for uncertainty, because insurance providers have to remain solvent, so they have to understand what they may or may not know, and to the degree that there's uncertainty, they have to add additional to cover that cost. There's also the cost of overhead and the price of money. So if we think about a community-based insurance program, that gives us three knobs to turn. You can either work to reduce the risk, you can work to reduce the uncertainty. Certainly by aggregating the policies together, you can reduce the overhead costs. And by working with the community, you can reduce the price of money. Next slide. So how would this happen? How might a community move forward with a community-based insurance program? Well, in California, we have a unique government entity. It's called a geologic hazard abatement district. It's often kind of referred to as a homeowners association on steroids. It was established in 1979, first established in 1979, to deal with the issues of landslide risk. It is a independent state level entity that is authorized to oversee geologic hazard prevention, and the movement of water over earth is, it's written broadly enough that it includes that kind of risk. So we feel that it's an opportunity to use this mechanism. One of the things that makes it attractive is that the boundaries can be drawn however you need to draw them. So you are not confined to the political boundary. So when we talk about a community-based insurance program, I'm not talking about the political definition or community, but a community as in a collection of homes. Next slide. So one of the benefits, or a number of benefits for a geologic hazard abatement district, is that you can combine both the mitigation and the insurance to reduce the risk. You can also use it as a way to fund flood fighting and a way to initiate faster payouts. Next slide. So potentially through a community-based insurance program, you could see immediate savings in an NFIP. As I mentioned, you can see cost savings through combining the insurance with flood risk reduction measures. It also provides an opportunity to provide better coverage options than the NFIP. Next slide, last slide. Next slide. So I'm just looking for areas that are interested in being a pilot. And so if you have a community and an area where you think there would be interest in a community-based insurance program, please reach out to me. So I look forward to having a conversation. And with that, I'll turn it back over to Stas. Thank you.
Kathy, thank you very much. So one of the questions, Luca Citoni sent a question. Kathleen, did you see it? Kathy, did you see it?
Actually, the question is, do insurances have interest in paying for flood mitigation activities themselves? The answer is yes, actually. I'm working with Munich Re, and they see the benefit, and we're looking at how we might roll that into a policy.
Okay. Tony, are we getting any, you and I talked about the 100-year flood projections, and you've heard in the Netherlands, and as you know, because of your association with Deltares, in Europe and in the Netherlands, they're talking about what, 1,000-year and 10,000-year events. You've talked about the methodology being outdated and its relevance to insurance. Do we need to be thinking about going out further? I know you noted that there are challenges, but are we missing a whole lot of stuff? I mean, Kathy's talking about a whole lot of things that are not there. Is 100 years being part of the problem?
So I think there are a couple things in that statement to dissect. The first one is that it's really important. There's a lot of comparisons made between the Dutch 10,000-year standard and the US 100-year standard. And I think it's really important to recognize that The Dutch standard is a level of safety, which is a little bit different than our return period approach. So in the Netherlands, you're balancing sort of cost benefits when setting that safety standard. And that's where that 10,000 year number comes from. So and the details of that are mind boggling, and probably one of my Dutch colleagues could jump in and give us a whole spiel. But I think it's really important to recognize that there's something a little bit different going on there in how these return periods are calculated in the two systems. The other piece of that is that I do think we need to be talking about setting safety standards beyond this 1% chance in any given year. Places like Houston are moving towards using the 500-year floodplain as a regulatory standard for building codes. So that's just an example of a place that's already doing that, because they recognize that the 100-year floodplain is not enough to really assess risk in the city. And one of the reasons they're jumping to the 100-year is because it provides a really easy thing that's already modeled for them to use for building codes, but they are currently undergoing a remapping of all of the floodplains in the city to better account for pluvial flooding, and how that's going to translate into changes to regulatory standards is still a little bit unknown, because it's going to be using new model products that haven't yet been implemented in other places for that purpose. So I do think we need to move towards capturing more types of flooding. There's a couple of examples out there. There are new HEC-RAS models out there that are being used, but I think it is a science challenge as well as a policy challenge that we're facing in trying to figure out how to capture these bigger extreme events.
Thank you. And Mary, you have noted in your research report that the rainfall from Hurricane Harvey really, the coastal spine isn't going to protect against that. So if the rain starts coming along the lines of a Harvey event, what happens to you in the Houston area?
Yeah, that's a good thing. I think there is no single solution for the compounding floods that we discuss and worry here. Yes, coastal spine certainly will not prevent the excess precipitation. It just prevents the surge event. So I think just relying on coastal spine, which will likely also induce the development in those areas, could potentially also increase the vulnerabilities, right? We see this in many other places. If you have a coastal spine, this may also alter the like 100-year floodplains, may seem them more safe because of that, but this sort of a safety paradox that draws more development could potentially exacerbate the impact. So I think it should be more comprehensively assessed and combined with the land use change, the plannings, the buyouts, and other things where we see that vulnerability hotspots still remain, and we cannot solve this problem just with one coastal spine.
Thank you. Kathy, Moody's, tell me what Moody's is doing now to find, would you repeat that?
Yes, so most insurance companies use what's known as a catastrophe model to model and assess their risks. It's different than what FEMA uses. At least it's different from what FEMA has traditionally used. And a company called RMS, located here in the Bay Area, headquartered here in the Bay Area, Moody's just paid, as I said, $3 billion to acquire them and their technology. So it's quite astounding. But Stas, I wanted to just, on the issue of kind of the recurrence interval in the Central Valley, we have a 200-year standard, which is in the Bay Area, we continue to use the 100-year. So my quip is that as we go forward, the peaches and plums of the Central Valley will have a higher level of protection than the apples and Googles of Silicon Valley. So,
oh dear. Okay, that's a good quip there. Now, Moody's is going to be assessing the ability of the county to repay in a catastrophe. So that's not just flooding, that's all events.
That's
right?
all events, yes.
can you send me something on that? If you have a link on that, I think that's very useful. Don Davis, you keep laughing. I wish I knew what you were laughing about. Are you going to share this with us?
I think Kathy's analogy to the valley and the fruits of the bay was perfect.
All right, Kathy.
Awesome. She's a winner.
Forewarned is forearmed. Okay. Guys, thank you very much. I would like to go further, but we really are jammed on our time, and our last two presenters are an hour late, so I want to get them on. It is relevant to the San Joaquin Valley. Oh, one thing, Kathy, the insurance companies, I know you've been talking about Munich Re, but is there anybody else out there that's being proactive on this community-based front?
Yes, there are a number of large insurance entities that are teamed with Munich Re, to include Swiss Re and another one called Willis Towers Watson, are all interested in this.
Okay, thank you very much. Okay, our last panel, desalination strategies. We have Randy Truby, president of R.L. Truby and Associates. He's going to be discussing the urgency of a desalination mobilization to address drought and fires in Western states. And the San Joaquin Valley, of course, is in the middle of a drought, and it has impacted the whole agricultural sector. And he's going to be followed by Kyle Hopkins, his partner at Ocean Engineering in Norway, who's going to tell us about the solution to the problem. Come on, Kyle, smile. We're going to have some fun here. But Randy, thank you again for coming back. We really appreciate this. You are one of the national experts on desal, and somebody said, well, why are we having a desal presentation here? Well, I live in California, and we just went through a whole fire period. We're in the middle of a drought. As I think Kathy or Tony pointed out, we either get floods or droughts, but the one area of California that has done well during the drought is the area of your San Diego County area. And maybe we should start by asking you, what is the reason for that success?
Sure. San Diego, a number of years ago, recognized that water was an ongoing problem here because we do get so little rainfall, unlike the northern parts of California, and we don't have any rivers and things. And so San Diego has lived on imported water for many years, and we imported more than 90% of our water from Northern California through the State Water Project or the Colorado River Authority. Well, what San Diego did was they said, we've got to do something better. And so they started looking at alternative ways. They did all the conservation things that you should do. They did leak detection and prevention and that sort of thing. But then they started looking at their brackish water, and they started desalting their brackish water using desalination. Then they moved on to seawater desalination and built the Carlsbad desalter, which is a 50 million gallon per day plant that provides about 10% of the water for San Diego. And now they're putting in wastewater desalination systems that will recover another up to 90 million gallons a day of municipal secondary sewage and reclaim it and reuse it. So this diversified strategy has reduced the amount of imported water that they require, and they are providing their own water locally. And it's really helped them, provided them with a modicum of drought proofing, and used along with the other things they've done. It's put them in a much better position than they were 20 years ago. And they want to continue that strategy. And what I'm going to talk about today is how other communities around the world are doing exactly the same thing, somewhat on a different scale.
Randy, do you want me to share the slides, or do you want to share?
Yes, let's start with the second slide. It's titled Summary.
All right.
Thank you. Yeah, the next slide, please.
Got it.
What I'm going to talk about today, I'm going to go through just a little bit of the historical evolution of membrane desalination and innovations. And it's really a pivotal point I don't want to be too glib, but the climate is changing and so is desalination technology. It started with brackish water desalting, seawater desalting came along, and then wastewater reclamation. And the pivotal year for desalination, a little about that, what that means. I'm going to move on to diversified desalination solutions. This is a technique that we are using in San Diego and they're using in other places around the world. It's a very interesting approach, and end up with sustainable desalination innovations. That is, the improvements are still being made. These improvements make desalination more usable and more cost effective. Next slide, please. Next slide, Todd.
Yeah, it's there. It
Yeah.
just, I think it's your
Sure.
connection.
Sorry, I've got it. There were two major innovations in desalination technology that took place in the United States. The spiral wound element was invented at General Atomic Company in 1964, funded by the US government, Department of Interior. And then later on, the TFC polyamide membrane was introduced in 1979, also funded by the US government. These two innovations are used in 99% of all of the desalination membrane systems installed around the world today. So truly the technology is an American innovation. Next slide. Just a picture of that first spiral wound element in 1964, made of window screen, masking tape, some rubber bands. And this was the device that actually proved that the patent was viable and that the technology would work. And next slide, please. You'll see what has come from that little innovation. This is the polyamide membrane that was developed in 1979, a cross section. It's basically a polyester fabric with a polysulfone support cast on top and a polyamide membrane, a very thin layer on the very top that does all the work. And this thing is about as thick as a piece of saran wrap or cellophane, very thin, very high-tech material, and again, developed under US government contract. Next slide, please. You put these spiral wound elements and this polyamide membrane together, and over the years, these large desalination systems have evolved. This is a picture of two systems in Israel, Hadera and Ashkelon. Next slide, please. This is a picture of the Carlsbad desalination system. And the Carlsbad system was also built by Israeli Desalination Engineering, operating here in California. Next slide, please. This is a picture of the Orange County Water District, and you can see that these things tend to look fairly similar, a whole array of pipes and manifolds. However, this one's quite a bit different in that it's treating wastewater. It is reclaiming municipal secondary effluent and using it to supplement the groundwater in the whole Orange County area. This plant was installed in 1977 at 5 million gallons a day. It was so successful, it's now been expanded to 130 million gallons a day. Next slide, please. Just to give you an idea of what the dollar amounts are, in 2015, there was 528 million gallons of seawater capacity installed that year and 264 of brackish and wastewater. By 2019, that's gone up to 2.1 billion gallons a day of seawater and 438 million gallons a day of wastewater, brackish water and wastewater combined. Next slide, please. This is a chart that will show you the growth of desalination technology projected out to the year 2030. And I just got brand new numbers yesterday that I didn't have in time to include in this presentation. The actual new contracts installed for desalination systems, brand new systems, was $5 billion in 2019. And by 2023, it will be $9 billion. That's new equipment only. Once these plants were installed, they run for years. They have replacement membrane that gets provided to them and that sort of thing, so that the market value is much higher than that, but the new build is going up very rapidly. Next slide, please. As I said, 77 was a pivotal year. The first big seawater plant was built in 1977 and installed in Saudi Arabia. By today's standards, small, 2.3 million per day. Also, the first large wastewater system was installed in 1977 at the Orange County Water District. We just saw a picture of that. And the first large and the biggest desalination system built for many decades was the Yuma desalting plant, which treats irrigation return water. All of these plants were built and designed using that spiral technology with polyamide membrane and were built by General Atomic Company. Next slide, please. What's evolved in current years is that there's a diversified solution, diversified desalination solution being applied by communities around the world. Singapore is a beautiful example. In Singapore, you have a very large population on a small island, and there is no room for reservoirs. There's certainly no rivers and lakes and things like that. They basically live on rainfall that they can catch, and they do quite a bit of that. They've educated their population to be water careful. And for years, they imported water from Malaysia across the narrow strait through a pipeline. This turned out to be very unreliable. Today, they have mega plants installed throughout the island. They have 5 major seawater desalination plants, and they have 6 major wastewater reclaim desalination plants. And all of these plants together have made the island much more sustainable, much more reliable source of water for all of their population. One of the interesting things about this diversified desalination approach is you treat the water twice. You're actually using it over and over again. You desalt seawater, which provides you with a new source of water for your population. It's used by the population and then collected as wastewater, which normally would be treated as sewage, clarified and dumped. But if you add that 4th stage, you can desalinate that water and reuse it again. And that's exactly what they're doing in Singapore. And they did a great job of educating their population. And they do direct recycle. That is, they take that desalted municipal secondary effluent and they put it directly into the drinking water system without a natural break. So they are using that water twice, and it's been very effective. Australia is doing a similar thing. Australia takes seawater and has huge seawater plants in Sydney, Melbourne, Gold Coast, Adelaide, and Perth. They now also are installing wastewater recycle plants, and they have 3 or 4 of those in Brisbane, and they're adding more. And so Australia is using the same sort of approach to augment their water supply because they too are in a very dry area. One of the things about these places, Singapore and Australia and even Israel, which has a huge number of desalination systems, these are not oil-rich countries. These are countries that rely heavily on what they can produce in their own country. And so they are not using desalination only because they can afford it. They've found a way, they value the water, and they have found a way to come up with the funds to pay for it because it has value to them. Next slide, please. The New York Times recently wrote an article about San Diego, which was very interesting. San Diego has historically, as I said, imported their water from Colorado River in Northern California. And they put together this aggressive program, including recycling for landscape use, recycling the wastewater. And this approach has worked very well for San Diego. And they're now going to build 2 huge wastewater plants that will go online in the next 5 years that I said will recycle another 60 to 90 million gallons a day of water. Next slide, please. There are concerns about the use of desalination, and whenever we have the public meetings, people are worried about the energy consumption, the environmental impact. There are social concerns that putting a desalination plant is often cited in an area that there's low-income housing near the beach, and it sometimes gets displaced. And so these are things that are concerns about using desalination. Many of these items have already been addressed to a very high extent. Solar power can be used to drive. You can go to the next slide. Solar power is being used to drive these plants. In Perth, Australia, when they built the seawater plant, they also built a solar wind or a solar field that provided the energy to drive that seawater plant. It's not direct connected. They put the energy into the grid and the seawater plant takes the energy off the grid, but they put enough to make up for what the desalination plant uses. And you can do that anywhere. And they're doing it in the Middle East now as well, where they want to keep their oil for other things. They want to use their solar power and wind power to drive their desalination plants. The desalination plants have come down in energy consumption by 50% since 19. And there's other enhancements that are being made. Desalination is changing, and it's changing rapidly. Next slide, please. One of the new innovations, and Kyle Hopkins, who follows me, is going to talk about a great one that I think has real potential. I'm going to talk about a different one right now. This is a new company called Cynata, and it's just an example of the kind of things that we can look forward to going ahead. Cynata is a new company started by a very bright young man. The technologies got the Water Technology Idol Award for 2020 from Global Water Intelligence magazine. It's a software system monitoring supervised machine learning and algorithms to lower the energy cost of desalination. Next slide, and let's go to the slide after that as well. Could proceed on, Todd. Next slide. This shows a little bit of how Cynata works. They get the raw input data. They do a data cleaning operation, validate, and then use that input to optimize the operation of the desalination system. Next slide. This is a graph that shows the impact that they can make. The red dots are the energy consumption of a plant. They had a significant reduction in the energy consumption that the plant was using. Next slide. This shows a analysis that was done in Australia, an audit of the impact that could be had if they used the Cynata technology on their big desal plants. Next slide. And it shows that if you've got a 300,000 cubic meter per day seawater RO and apply the Cynata technique, you can improve the operation by about 10%, which is equivalent to 13,000 tons of removed carbon dioxide, or taking 4,546 cars off the road. So it has a significant impact and can really improve the operation of these plants and continue to reduce energy above and beyond what the membranes and the energy pumping systems have done. Next slide. Basically, desalination is a tool. It's changed and improved over the last 50 years. It offers a diversified benefit to water stakeholders, and it can be part of a sustainable, reliable water supply, enhancing the quality of life and including combating wildfires and drought. One of the things it could do, and it's doing in San Diego, as San Diego uses the Carlsbad desalter and wastewater reclaim, we don't have to bring water down from Northern California, and that water can go to irrigating the Central Valley for crops and for all of the other things that they need there. I think one of the strategies that should be used is communities that are near the coast should use seawater desalting, which would free up water inland, like the Colorado River, for inland, like Phoenix and Las Vegas. I think that a regional approach is going to need to be used in many of these cases, and it should result in significant improvements. Kyle Hopkins is going to talk about his technology and partnerships going forward and improving desalination even further. Stas?
Thank you very much, Randy. As always, it's an education listening to you and learning about what's happening in desal and how this very, very crucial resource of water needs more emphasis, needs more support, and it needs to be part of our infrastructure investments. Kyle Hopkins, thank you very much for being so patient and hanging out with us till the very late evening in Norway. And you've been a great resource for us in our last conference. And I want to thank you very much for joining us again.
My pleasure, Stas, indeed. And Todd, if you would like to bring up my slides, please.
Sure.
I'll just start by thanking all of the prior presenters. It's certainly been, I'm just making sure everybody can hear me. We got a thumbs up.
I can hear you.
Yes.
Okay, it's certainly been an educational experience, and I just want to thank everybody for the exceptional work that they're doing. Thank the speakers, but also other people attending the conference, that there's a lot of exceptional work being done. And I'm going to build on a theme that started off very early at the kickoff. I think it was Joe talking about partnerships and talking about working together, and we can't do it alone. We can't just work and live in our silos anymore. We need to expand beyond that. And let's take a look why, and start by looking at a number. Todd, next one, please. That number is 49 billion. Economic impact of California agricultural sector last year was 49 billion. In 2019, it was 50 billion. So clearly we all are familiar with the importance that the Central Valley plays in the agricultural sector in global food security. Specifically, almonds have grown very rapidly to a $6 billion industry. We're all familiar with CalRose and the dairy industry in California, and of course, the fruits and vegetables. And all of this has been critical to national and international food security and global and domestic and state economic growth. However, we also know about the water crisis and the problem that farmers are facing every day, and they have been facing increasingly frequently over the years. Almond farmers are tearing out their almond trees because they don't have water to provide for their plants. And some are even stopping farming altogether and selling their water or selling their water rights and looking at setting up solar panels or doing something else in the interim in hopes for a better rainfall in the future. There's some estimations that by 2040, 1 million acres in California's Central Valley are going to be fallow. So that's going to have tremendous implications on the economic viability of the agricultural sector in the Central Valley, let alone the livelihood of millions of people who have worked so hard and lived to make it a real breadbasket of the world. So we have this background that many of us, especially those of you in California area, are facing on a day-to-day reality with the water crisis. There is the Western Water Coalition, and I thank them for understanding my ability to only handle one large number at a time, because their number for 2022 to 2032 in terms of the investment required for the water infrastructure is 49 billion. And 1 billion of that is earmarked for desalination. 200 plus groups have signed letters to Congress asking for action on the water infrastructure needs. And as many speakers have said, action is coming, it's taking some time, but the need is in front of us and it's very dire. Let's take a look at how we got here. Next one, please, Todd. Some of you are likely familiar with these graphs about the great acceleration. Now they're a few years old, but they still tell the story. Rapid population growth, growth in GDP, water use increase. But let's be clear, all of us have benefited tremendously from these graphs, from this consumption. Millions of people have been brought out of poverty, improved the quality of life, improved learning outcomes, life outcomes. This has been a tremendous boon for our species, for people everywhere in the planet. But what is the planet telling us in return? Next, please. We're coming up to, and in some cases, going beyond planetary boundaries. We have carbon dioxide, nitrous oxide, methane, we have ocean acidification. And the one that really always strikes out to me is this shrimp farming one. In most of our generation, or in our lifetime, we went from barely farming any shrimp to 4 million tons plus a year of shrimp farming. So the plan is telling us, this is hard work, guys. This is taking a toll. And many speakers have more eloquently brought up that point in their topics today. But we all understand we need to take a new address. We need to find new solutions, new ways of thinking. Randy presented a fantastic one with using machine learning and technology to reduce energy consumption. And I want to go back to California and to that key role of partnership. Next slide, please. If we look at partnership, there's really 3 different levels, and this is not my research by any means. It comes from the UN. First level, we have transactional partnership. This is where business is conducted and people are happy. This is my partner with whom I work. At the second level, it's more long-term. We could think of it like a joint venture. 2 organizations coming together to meet a mutually beneficial goal. But what we really need is transformative partnerships. And if we go back to the California water crisis, we have all the components to create transformative partnerships. We have the local, state, and federal governments. We have the Department of Defense and many bodies therein that have very clearly articulated their abilities and their will to address these challenges. We have the ports that are always so on the front edge, pushing international trade, pushing innovation, changing and growing, as we saw in Daniel's presentation, as we learn about what happened in Singapore. The ports are a key component to this. We have the research organizations, as we have members from various universities, and in California, of course, there's Stanford, Berkeley, and many others that are very well established in the research field. We have the architect and engineering firms that have a global knowledge base and capacity. And then we have the third sector, the NGO groups that are always pushing to do the right thing, always getting more research, and they're a tremendous resource, particularly in California, where many strong organizations are active locally, in the state, and globally. And then we have the innovators, small companies that are coming up with ideas, spinning out of large companies, bringing innovations to the front. And all of these are very important. If we look at our technology, the water fountain, it's an offshore desalination system that's scalable. We can have a spar buoy, which is placed in clusters offshore, or it can be a ship-based unit, or even a repurposed semi-submersible rig. The purpose is to create desalted water with lower energy consumption, not producing brine, and reducing any environmental impact every step along the way. One thing that we could look at, offshore floating wind is finally taking root in the United States, and we can couple offshore wind turbines with offshore desalination to, as Randy was suggesting, use desalination to serve the needs of the coastal urban population, which allows more of the 50% of the diverted water that goes to agriculture already in California to maintain the agricultural sector in the Central Valley. And even at scale, as I was referring to offshore rigs repurposed, water can be provided to the agricultural sector directly. There's a lot that can be done, and we understand the challenges. We understand the importance of partnerships. My challenge to all of us is to not only sit back and to look at all of the different ideas, to talk about the ideas, to look at the challenges and to consider innovations and approaches, but to do that and to take action, to find how can we pilot a technology? How can we incorporate innovation? How can we closely collaborate with universities and innovators out there? I have many ideas, and I think many people on this call have better and more ideas, I'm sure. What I'm challenging us to do as we wrap up is to start taking more steps as we can and build together in transformative partnership to take those pilots, to find that extra funding, to reallocate, to move forward quickly so we can reach the vision and reach that high level solution that we know is possible with all the different technologies and the great minds that are working at this. And Stas, thank you so much for your perseverance and organizing here. We know you work tirelessly to make such a good production, and I'm very grateful.
Well, Kyle, thank you very much. That was that's a good strategic view that you provided us. Tell us, what is the status of your module for water fountain, and when are we going to start seeing it in commercial use?
Yes, thanks for the chance to talk about that, Stas. We are finishing the design. In fact, we had a milestone this week. Our specially built compressor, which is a no oil compressor, of course, because we don't want to contaminate the water. It arrived in our workshop here in southern Norway, just down the road from my place a few days ago. In fact, we got it off the truck and into our workshop. So that was the last big piece that we need. We finished the designing of the subsea unit. The membranes are placed 350 meters below the surface, and we use a compressor to, with our patent, reduce the energy consumption by using the naturally occurring physics, which include the atmospheric pressure at depth, but it's not entirely driven by that. We are finishing the first spar unit buoy engineering, which then will become the workshop build design papers. I heard a few times projects are a little bit delayed, and we had a COVID and a supply chain challenge, and we're also have suffered with that a bit. So to answer the question about commercial use in the first unit, that is going to be the summer of next year, towards the end of the summer. In fact, we are facing a challenge that many new innovators face, in that we have clients both in Asia and in the Middle East who are very interested and capable to employ water fountains, certainly on a financial and an operational sense, in that they have the contractual need to deliver water, and they want to do it in a more sustainable and economic way. The challenge I'm referring to is this performance guarantee risk. And there are groups actually in the Bay Area who are very good at de-risking innovation and allowing the investor set. Our clients are convinced. The patent is clear, the science is clear, this works. But on the financial level, de-risking the financial risk is the one final hurdle that I'm getting to, and I have some tools to get over it now. So I'm confident that as we go forward, we will be entering into those contracts with holders of offtake agreements, and you'll be seeing it operating in next year.
Thank you for that, Kyle. If you could send me anything that you're doing on the background or describing this, we would be very happy to distribute that. So if you wouldn't mind doing that.
Absolutely.
Okay, thank you. Randy, interesting, we've gone from 5 to 9 billion in new builds for desal. That's a promising sign, isn't it?
Yes, and that's just that's in that 1 year period. In other words, it's not that's a reflection of how many new systems are being built. Just to give you an example, the Carlsbad desalter cost $1 billion and makes 50 million gallons a day. So if new builds, and if they were all the same size, it would be another 250 million gallons a day of desalted water capacity. Of course, 9 billion would be is really almost twice that. So it's a significant ramp up in the number of large desalination systems that are being built around the world, and they're being built all over. There's new projects planned for Texas. There's new projects, and we're still working on Huntington Beach, and that's still under review by the California Coastal Commission. It's got some hurdles to overcome, but it's still moving forward. But there are projects, another project in Singapore. There's projects in Australia coming up. There's projects in South America. and always in the Middle East. They rely exclusively on desalted water and have for many years. And it's always been a huge market and continues to be. One of the interesting things is the Middle East is now putting in wastewater reclaim plants. There's a 60 million called Sulabaya, and they are starting to recognize that they want to do some things that are being done in the rest of the world, where you take treated sewage and instead of dumping it back, recycle it, use it again, and they're going to use that technology to do that.
Very good. Thank you. This brings us to the conclusion of our day, and I want to thank Randy and Kyle for their contributions, and I want to thank everyone else who stayed in here. It's been a long day. I want to thank our sponsors once again, Customs Brokers and Forwarders Association of Northern California, Mead & Hunt, Stantec, and Watermaster North America. One last word, and of course, the Society of American Military Engineers and my friends Arvin Acharya and Jamil Ibrahim and Catherine Roscoe. And thank you to all the same members for being here and for your support. And we really appreciate that. Jim Patty at the Propeller Club, I don't know if he's still here. But thank you, and thank you again to my board. We have to face the one really chilling fact, and that is that infrastructure investments of the kind that we are talking about are way behind what the need is. The shortfall is getting worse every year. The infrastructure bill that was passed by, that has not been approved, but has been passed by the Senate and is going to the House, is not enough. It's enough maybe to backfill the shortfall of 40 years of neglect in infrastructure. Today, you've had a chance to hear from innovative people who are on the cutting edge of a number of areas, insurance, flood risk, coastal spine in Texas, desalination in California and Norway. You've heard about innovations in the Netherlands, using water to both store and to protect. You've heard about global dredging practices from Jamie and from Boskalis. You've heard about what plans there are for moving forward with insurance. And there are so many areas, and also the work that's being done by Deltares on cascading infrastructure. The problem here is that we are reacting, we are not innovating, we are not staying ahead of the problem. And what's going on in Washington, whatever happens, it's not going to be enough. And you've heard expressions at the COPE climate change conference in Glasgow that scientists are increasingly concerned that we're not moving fast enough, that we are allowing disputes over how much fossil fuels we're going to keep into the system to prevent us making the transition over to renewable resources as quickly as we can, while making sure that we safeguard the economic well-being of our people in the United States and those who rely on traditional sources everywhere. We are not moving fast enough. It's a sad situation to say, but it is true, and we need to do more. At least today, you've gotten the opportunity to hear from a number of innovative people, and we hope to continue those contributions in the future. I hope very much that we'll see an aquatic transfer station at some point, Peter, that we'll see the dredgers of Watermaster being deployed in the United States and California, that we're going to build more dredgers, that we will give the support to the Army Corps of Engineers to do research and development and engineering so that people like Mark Wingate and Rudy Simino and the people supporting the coastal spine in Texas can move forward and make those things happen. So I want to just conclude with, there is always light at the end of the tunnel. We need to have hope in the future. And those of you today who contributed and participated helped that process along. Thank you very, very much for all of your assistance and all of your knowledge and research. And we hope to be able to mobilize that next year, hopefully in a live setting, but in a setting nevertheless. And thank you all very much. See you next year.
Thanks. Bye, Stas.
Thank you, Stas. It was a very good presentation.